Alright, so our first topic is the origin of soil. So our book reference is The Principles of Geotechnical Engineering, 7th edition by Braha M. Das. So the mineral grains that form the solid phase of a structure of a soil aggregate are the product of rock weathering. So the size of the individual grains varies over a wide range. Many of the physical properties of soil are dictated by the size, shape, and chemical composition of the grains. To better understand these factors, one must be familiar with the basic types of rock that form the Earth's crust, the rock-forming minerals, and the weathering process. So on the basis of their mode of origin, rocks can be divided into three basic types: the igneous, the sedimentary, and the metamorphic rock. So here we have the rock cycle. First, we have the igneous rock, which it will undergo transportation, erosion, and weathering process, causing it to produce its sediments, and this will undergo compaction, cementation, and crystallization, which will later then become sedimentary rock. So these sedimentary rock will go through the process of metamorphism and will produce metamorphic rock. So once this metamorphic rock melts, it will create magma, and then the rock cycle continues. So first we have the igneous rock. Igneous rocks are formed by the solidification of molten magma ejected from deep within the Earth's mantle. So after ejection by either fissure eruption or volcanic eruption, some of the molten magma cools on the surface of the Earth. Sometimes magma ceases its mobility below the Earth's surface and cools to form intrusive igneous rocks that are called plutons. So intrusive rocks are formed in the past, may be exposed at the surface as a result of the continuous process of erosion of the materials that once it is formed from magma that cools and solidifies within the Earth's crust. So its structure is coarse. It is abundant with quartz, sodium feldspar, potassium feldspar. So it does not have much of biotite, muscovite, and the other one. So we also have here the rhyolite, the gabbro, the basalt. So these are the kinds of igneous rocks and their mode of occurrence, their texture, and the minerals that are abundant in each of these kind of rocks. So the igneous rocks go through the process of weathering. So weathering is the process of breaking down rocks by mechanical and chemical processes into smaller pieces. So there are two types of weathering. We have the mechanical and the chemical. The weathering process is not limited to igneous rocks. So sedimentary and metamorphic rocks also weather in a similar manner. So meaning it is not only the igneous rock that go through the process of weathering, but as well as the sedimentary and the metamorphic rock. So uh, we can see how the weathering process changes solid rock masses into small fragments of various sizes that can range from large boulders to very small clay particles. So uncemented aggregates, these small grains in various proportions form different types of soil. So since we have two types of weathering, we have the chemical and the mechanical. Let us first talk about the mechanical. So mechanical weathering may be caused by the expansion and contraction of rocks from the continuous gain and loss of heat, which results in ultimate disintegration. So frequently, water seeps into the pores and existing cracks in rocks. As the temperature drops, the water freezes and expands. The pressure exerted by ice because of volume expansion is strong enough to break down even large rocks. Other physical agents that help disintegrate rocks are glacier ice, wind, the running water of streams and rivers, and ocean waves. So these are the contributing factor that help disintegrate rock. So makatugmok siya sa mga bato. So it is important to realize that in mechanical weathering, large rocks are broken down into smaller pieces without any change in chemical composition. So whether it is in large or small pieces, their chemical composition remains the same. So another type of weathering is the chemical weathering. In chemical weathering, the original rock minerals are transformed into new minerals by chemical reaction. Water and carbon dioxide from the atmosphere form carbonic acid, which react with existing rock minerals to form new minerals and soluble salts. Soluble salts present in the groundwater and organic acids formed from decayed organic matter also cause chemical weathering. So we have the transportation of weathering products. The products of weathering may stay in the same place or may be moved to other places by ice, water, wind, and gravity. So the soils formed by the weathered products at their place of origin are called residual soils. An important characteristic of residual soil is the gradation of particle size. Fine-grained soil is found at the surface, and the grain size increases with depth. At greater depths, angular rock fragments may also be found. So meaning, as the depth increases, so as you go deeper from the surface, the grain size of the soil also becomes larger. So it is said here that fine-grained soils are found at the surface. So soils with soils in larger or bigger sizes can be found in greater depth. So the transported soils may be classified into several groups depending on their mode of transportation and deposition. So we have the glacial soils. They are formed by transportation and deposition of glaciers. Alluvial soils are transported by running water and deposited along streams. Lacustrine soils are formed by deposition in quiet lakes. Marine soils formed by deposition in the seas. Aeolian soils transported and deposited by wind. And last one, we have the colluvial soils. They are formed by movement of soil from its origin place by gravity, such as during landslides. So after going through the process of weathering, we come up with the sedimentary rock. Deposits of gravel, sand, and silt and clay formed by weathering may become compacted by overburden pressure and cemented by agents like iron oxide, calcite, dolomite, and quartz. Cementing agents are generally carried in solution by groundwater. They fill the spaces between particles and form sedimentary rocks. Rocks formed in this way are called detrital sedimentary rocks. Okay, all detrital rocks have a clastic texture. The following are some examples of detrital rocks with clastic texture. So we have here the granular or larger sizes of sedimentary rock, the sand, the silt, and the clay. So sedimentary rock also can be formed by chemical processes. Rocks of this type are classified as chemical sedimentary rock. So sedimentary rock may undergo weathering to form sediments or may be subjected to the process of metamorphism to become metamorphic rock. So sedimentary rock that goes through the process of metamorphism becomes metamorphic. So those were the three types of rocks where our soil basically comes from. So now let us proceed to soil particle size. Okay. Soil generally are called gravel, sand, silt, or clay, depending on the predominant size of the particles within the soil. So, to describe soils by their particle size, several organizations have developed particle size classification. So, a soil can be called gravel if its predominant size is of the size of a gravel. So a soil can be called sand if its predominant size is of that size of a sand. So a soil can also be called a silt or clay depending on what is the dominant size of the particles within the soil. So we have the four most common soil particles. So we have first the gravel. Gravels are pieces of rocks with occasional particles of quartz, feldspar, and minerals. So another particle size of soil is the sand. So sand particles are made of mostly quartz and feldspar. Other mineral grains also may be present at times. So another particle size is the silt. Silts are the microscopic soil fractions that consist of very fine quartz grains and some flake-shaped particles that are fragments of this type of mineral. So another type of particle size of soil is the clay. Clays are most flake-shaped microscopic and submicroscopic particles of mica clay minerals and other minerals, meaning the clay is the smallest particle size of soil. So clays have been defined as those particles which develop plasticity when mixed with a limited amount of water. So what does this mean? So it is said that when the clay is mixed with water, um, it can develop a certain type of plasticity. If the soil has a size that fall within this range, it is called a gravel. So also according to them, if the soil particle is of the size between 2 millimeters to 0.075, it is considered a sand. So silt are those soil particles that are of the size 0.075 millimeters to 0.02, and then um, clay is just the same with the other two. Is of the size of 0.002 millimeters or less. So another one is the unified soil classification system, also one of the most commonly used. According to them, 76.2 to 4.75 millimeter soil particles are considered to be gravel, and soil particles in the size of 4.75 millimeters to 0.075 millimeters are sand. And for those soil particles that are less than 0.075 or smaller than 0.075 millimeters are considered to be silts and clays. So we also So these sieve openings, there is a note here. So sieve openings are of 4.75 millimeters. So sieve meaning ayagan. Sieve openings at 4.75 millimeters are found on a US number 4 sieve. So marag kuan lang ni siya, marag provision lang na siya sa sieve openings. So mechanical analysis of soil. So how do we know? How do we know how much gravel and how much sand and how much silt are present in our soil? For example, we have excavated a soil from a source, and how do we know from that soil that we have obtained how much of that is gravel and how much of that is sand and how much of that is clay. So we have the two methods to be able to find the particle size distribution of soil. So particle size distribution meaning how much gravel, how much silt, and how much clay are present in that soil, and how and what are their sizes. So we have the mechanical analysis of soil. Mechanical analysis is the determination of the size range of particles present in a soil expressed as a percentage of the total dry weight. So through mechanical analysis, we will be able to know the sizes of the particles present in our soil, and this is expressed as percentages of the total dry weight. So for example, we would say um, 30% of the total dry weight of this soil that we have obtained is gravel. So we could also say 20% of the total dry weight of this soil that we have obtained is sand. So that is how we interpret the results for the mechanical analysis of soils. Although there are two methods generally used to find the particle size distribution of soil. So we have the most common for the testing laboratories here in the city, the sieve analysis. We will be using sieve analysis for particle sizes larger than 0.075 millimeters in diameter, and uh, if the particle sizes are smaller or mas pino than 0.075 mm in diameter, we will be using hydrometer analysis for mechanical analysis of soil. So we can assess what method are we going to use by visually assessing our soil that we have obtained, whether they have large sizes or large particle sizes, or whether they have smaller particle sizes. So it is up to us how do we choose between these two. So we first have the hydrometer analysis, which is not really very common. So hydrometer analysis is based on the principle of sedimentation of soil grains in water. When a soil is dispersed in water, the particles settle at different velocities depending on their shape, size, weight, and the viscosity of water. So as you can see here in the picture, there is water in a graduated cylinder, and then a soil is incorporated into the water. So I will be sending a YouTube video on how to conduct and what are the things that has to be done in hydrometer. So another type for the mechanical analysis of soil is the sieve analysis, which is very common. Sieve meaning ayagan. So in this picture, this is the one sieve size. So kani 1, 2, 3, 4, 5 are different sieves with different openings. So lalahi siya size. Lalalay kadakpan ang iyahang openings. So sieve analysis consists of shaking the soil sample through a set of sieves that have progressively smaller openings. So each of these sieves are stacked against each other, and they have um, progressively smaller openings. Here an example. So particle size distribution of soil, so ASTM C136 or ASTM D422, this is the standard provision which we follow in the conduct of the sieve analysis. So meaning ASTM is, or you can have it searched, pero this is an actual test result of the sieve analysis conducted on the soil, or one of the soil that I have studied in my thesis for master's degree. So this is an actual test result. So we have here sieve openings in millimeters and as well as in inches, and the percent passing of the soil per sieve opening, per sieve number. So for example, this is usually the test results that you will get from the testing lab from the conduct of the sieve analysis. So for example, for the 75 mm opening of sieve, there are 100% of the soil have passed. So that is what the percent passing means. So in vernacular, 100% sa katong soil ang ni-pass through the sieve nga naay opening nga 75 mm. So kaning sieve opening magkaanam ni siya kapino, and then magkaanam pud og kagamay ang mulusot ato nga kada sieve. So for example here sa 25 mm opening opening of sieve, so ang sieve na naay 25 mm opening, 100% pa daw ang ni-pass. However, when the soil have passed through the sieve with opening of 19 millimeters, 98% na lang. So for the 12.5 millimeter opening sa sieve, 91 na lang. So magkaanang mo kagamay gid ang opening sa sieve, and magkaanang mo kagamay ang makalusod nga soil. So from this data, how do we know how much gravel, how much sand, and how much silt and clay? So that is basically the goal why we conduct sieve analysis. So according to the Unified Soil Classification, wala atong gamitan among the 4 classification system, we will be using the Unified Soil Classification because it is way easier and easier to understand, easier to comprehend. So according to the Unified Soil Classification, soils that are greater than 4.75 millimeters are called gravel. So if we are going to look in the test result, we are going to look for the 4.75 millimeter sieve opening. So we have here sieve number 4 and with sieve opening 4.75. The test result is percent passing is 80%. So meaning 80% of the soil is smaller than 4.75. Meaning if the soil is 100%, 80% ang nakalusot. So 4.75. So what is the implication of that? 80% of the soil is less than 4.75 millimeters. So, ang katong mga na-retain, which is equal to 80%, 100 minus 80 nga nilusot sa 4.75 mm opening sieve is equal to 20, which is mo to sila ang mas dagko sa 4.75 kay wala man sila nilusot atong sieve. So, meaning 100 minus 80 is equal to 20% gravel. So according to the test result, the soil that I have obtained for my study contains 20% gravel. Now for the determination of the percentage of sand, according to the Unified Soil Classification, it is the percent finer or the percent passing at 4.75 mm sieve minus the percent passing or percent finer than 0.07. So the word percent finer than and percent passing is used interchangeably. So I hope you don't get confused with that. So according to here, we have to subtract the percent passing at the sieve 0.075, or that is sieve number 200. We will have to deduct that from the percent passing at 4.75 millimeter opening sieve or sieve number 4. So first we have to identify the percent passing or percent finer at 4.75 millimeter opening sieves or sieve number 4. So we have here. So that is 80. So we will subtract from that the percent passing at sieve number 200 or 0.075 millimeter opening sieve or 51%. So 80 minus 51 is equal to 29%. So that basically means that the soil that I have obtained contains 29% sand. So now for the determination of the percentage of silt and clay, it is automatically the less than 0.075 millimeter amount of soil. So meaning it is those soil that pass through the 0.075. Okay, you can say that there are less than 0.075 millimeter kay nilusot man sila ato nga sieve. So meaning mas gamay sila. So basically, automatically our silt and clay is the percent passing at sieve number 200 or 0.075 millimeter equal to 51%. So how to check if, so that means that the soil that I have obtained um, contains 51% clay, meaning more than half or almost half of the soil that I have obtained is clay. So how to check if you did the right thing in the computation? If you add these three percentages, it has to be equal to 100%. So I think that would be all, and thank you.